To better understand how certificates and SSL work, you first need to understand the basics of encryption. Picture this: a user wants to connect to a server. If a hacker was between the user and the server, the hacker could eavesdrop on the communication. If the communication was not encrypted, then the hacker could capture information like passwords, usernames, and data. The hacker could even hijack your session after you enter your username and password. When this occurs, the server thinks it is still talking to you, and the hacker can insert their own commands as you. A hacker could even record the communication between you and the server and then replay it back at a later stage. Other forms of attack include the hacker intercepting data as it goes over the network and then changing it or adding their own data. In this case, the user may be unaware this is occurring until it is too late. Certificates provide a method by which a user can confirm the identity of the party they are talking to. It does this by having what is called a certificate authority. To understand what a certificate authority is, think of it this way: any friend of yours is a friend of mine. A certificate authority, or CA, issues certificates to your servers. The certificate is signed by the trusted CA. The model relies on trust. The user trusts the CA and can verify the server certificate in fact came from the CA. Third-party CAs exist on the internet, like VeriSign, but depending on your needs, you may just want to install Microsoft Certificate servers and issue your own certificates. When an end user attempts to connect to a server, they obtain a copy of the server's certificate. The end user can then verify the server is who they say they are, as the certificate is signed by the CA, and the end user trusts the CA. If a hacker pretended to be a server, they would not have a valid certificate. Certificates use complex key encryption, relying on secret keys, so the hacker could not simply intercept client communication and generate their own certificate. If a hacker attempted to provide the user with a fake certificate, the user can quickly verify the certificate did not come from the CA. The user then knows the hacker is not who they say they are. Remember that unless your clients have certificates too, your server cannot verify the clients are who they say they are. Without client certificates, the hacker can still connect up to your network. Certificates verify people are who they say they are, and are not a replacement for other security measures, like usernames and passwords. In order for a client or server to use certificates, they first need to be issued by a certificate authority, or CA. Once you have certificates, you can use them for authentication and encryption. The certificate contains a private key and a public key used in encryption. The public key is given to the other party to encrypt data sent to you, which then can be decrypted with the private key. For this reason, it is important to keep your original certificate files safe. If a hacker was to obtain the original certificate files from you, they could use them to decrypt your communication. Installed correctly, certificates can protect your communication from eavesdropping and being altered by hackers. Let's have a look how ISS uses certificates. To set up certificates in IIS, first launch ISS Manager from Administrative Tools. From the Admin tool, select your web server and scroll down to the icon Server Certificates and open it. From the right-hand side, you can select the number of actions for creating and managing certificates. Firstly, you can import a certificate if you have it in a file. If you want to move a certificate from one server to another, you can export the certificate and then import it using this action. To create a certificate using a third-party authority, select the action Create Certificate Request. For the certificate, you need to enter some details about your organization. The file will be sent off to a third-party organization to generate a certificate, and once generated, can't be changed, so make sure you get the information correct. On the next screen, you need to decide what cryptographic service to use. The default is Microsoft's RSA S-channel cryptographic provider, which is supported by most third-party certificate authorities. Next, you need to set the bit length for the encryption key. The larger the value, the better the security. However, the larger the key will also increase the processing time taken to use a certificate. On the last screen of the wizard, you will need to enter a file name to save the certificate to. Once you save the certificate, you will need to upload it to a third-party certificate authority to be processed. Once the third-party certificate authority has processed the certificate, they will send you back a complete certificate in a file. Once you have the completed file from the third-party CA, this may take a few days, select the action Complete Certificate Request. Supply the wizard with the file given to you by the third party and then enter a friendly name in for the certificate. The certificate will now be added to your server certificates. Third-party certificates do cost money, and if your company does not need this kind of security, you may consider having your own certificate authority, or CA. Windows Server 2008 has its own CA for creating certificates. It is beyond the scope of this course on setting up Active Directory certificate services, but if you do have it set up, you can create a certificate by selecting the action Create Domain Certificate. This is much the same process as creating a third-party certificate. Since this is a test environment, I will just enter in some test details. Next, you need to enter in the certificate authority and the server that it is located on, as well as a friendly name. The certificate is automatically added, unlike the third-party certificate. Lastly, you can create a self-signed certificate. All you need for a self-signed certificate is a friendly name, since the self-signed certificate is signed by the local server. Self-signed certificates are mainly used for testing only. If you use a self-signed certificate in a production environment, the user will receive a warning when they access the server. On the Action panel, you will also notice an option Export. If you want to move certificates between servers, you can use this option. Also, you can export certificates if you want to keep a backup. If I select the View option, I can view details about the certificate I just created. One of the most important options being the valid to date. Certificates do expire after a certain amount of time. The Details tab will tell you more about the certificate, including the algorithm and the key length. Lastly, the certificate path will show the certificate in relation to the certificate hierarchy used in your company. In this example, there is not much of a hierarchy, but in an organization with a lot of certificate authorities, this can get quite involved. Once you have certificates set up on your network, you can enable Secure Sockets Layer, or SSL, to encrypt your data. Depending on the application that you are using, will determine how you need to configure it. Keep in mind that certificates provide the encryption keys, while SSL encrypts your data. Certificates and SSL go hand in hand together to provide a complete authentication and encryption system. In some cases, simply assigning a certificate to your application may not encrypt any data, unless you configure the SSL part as well. Let's have a look how to assign a certificate to a web page and enable SSL. In the ISS Management tool, expand down to your web page, select the web page, and then select the option Bindings. You will notice here that the website is already bound to HTTPS, which uses SSL. If I select Edit, I can change the certificate that the website is using. When you create a new website, you can specify the certificate to use or add a new binding to an existing website and then assign a certificate to that website. Since the bindings have been set up for this website, I can now change the SSL settings. Scroll down until you reach the icon SSL Settings and open it. You will notice by default, SSL is not required. This means a user could connect to this website without using encryption. Once you have ticked the tick box, you also have the option to tick the tick box Require 128-bit SSL. 128-bit encryption is a lot stronger than the default 40-bit version, but will require more CPU resources on your server to operate. Lastly, you can specify the option about client certificates. By default, the web server will ignore client certificates, making them a complete waste of time deploying them. You can change the option to Accept. This will accept the certificate if the client has one. Otherwise, you can set it to Required, which forces the client to have a certificate. In most setups, you'll want to make sure that you have certificates on your server to provide secure communication. Adding a client certificate only ensures the clients are who they say they are. If your website is connected to the internet and does business with the public, it will be impossible to issue client certificates to every one of your customers. In this scenario, it is best to leave client certificate settings on the Ignore setting. That's it for certificates and SSL. Remember, certificates verify who people are, and SSL encrypts communication.